So hello everyone, let's begin with the today's video assignment of COA. So the topic for discussion of today's video assignment is non-restoring division algorithm for unsigned integer. So first of all I would like to introduce myself. My name is Shivansh Rastogi from Computer Science and Engineering Artificial Intelligence. Okay, so now let's move on to the topic, non-restoring division algorithm for unsigned integer. The non-restoring division algorithm is more complex as compared to the restoring division algorithm. So actually the non-restoring division algorithm is difficult as compared to restoring division algorithm. But when we implement this algorithm in hardware, it has an advantage, that is it contains only one decision and addition subtraction per quotient bit. So implementing this non-restoring division algorithm for unsigned integer is an easy task in hardware than compared to the restoring division algorithm, because it has an advantage, that is it contains only one decision bit and addition and or subtraction operation per quotient bit. So after performing the subtraction there will not be any restoring steps. So we does not have to perform any restoring steps further, due to which the number of steps are basically cut down to half. So because of the less number of operation, the execution of this algorithm will be fast. So basically this algorithm performs simple operation which are based on addition or subtraction. In this method we will use the sign bit of register accumulator denoted by A, and 0 is the starting value, and that is we will initialize the register with the 0. So okay, so now let's move on. So now let's move on to the flowchart. So flowchart, you can see currently I am zooming the screen so you can all can see in a clear way. So first we are starting and initializing the n, that is n, what n denotes? N denotes number of bits in dividend. So okay, and A is accumulator. So as I have already told you that accumulator will be initialized with 0. So as you can see it is initialized with 0. M denotes the divisor and Q denotes dividend. Okay, so M and Q denotes divisor and dividend, which are stored in the form of binary numbers. Okay, so now let's move on to the next step, that is the sign bit of A. So sign bit basically क्या होती है? Sign bit होती है most significant bit of the number. साइन बिट ऑफ ए मतलब जो मोस्ट पहली बिट होगी ए की, उसको साइन बिट कहेंगे. अगर साइन बिट 0 है तो हम लोग ऑपरेशन लगाएंगे शिफ्ट लेफ्ट एक्यूमुलेटर में, एक्यूमुलेटर और क्यू में. क्यू तुम्हारा क्या है? क्यू है डिविडेंड, ठीक है ना. उसके बाद ऑपरेशन परफॉर्म करेंगे ए इक्वल्स टू ए माइनस वन, ए माइनस एम सॉरी. अगर साइन बिट ऑफ ए 1 है, यानी कि मोस्ट सिग्निफिकेंट बिट अगर 1 है, तो क्या करेंगे? तब भी हम लोग शिफ्ट लेफ्ट एक्यूमुलेटर करेंगे, लेकिन हम इस समय एक्यूमुलेटर में एक्यूमुलेटर इक्वल्स टू एक्यूमुलेटर प्लस एम करेंगे, मतलब एक्यूमुलेटर में एक्यूमुलेटर प्लस एम की वैल्यू स्टोर करेंगे. उसके बाद फिर से अब एक्यूमुलेटर की वैल्यू तो चेंज हो जाएगी क्योंकि ऑपरेशन परफॉर्म हुआ है. तो फिर हम चेक करेंगे साइन बिट ऑफ ए, और साइन बिट ऑफ ए आप सब जानते हैं कि मोस्ट सिग्निफिकेंट बिट होती है. तो अगर साइन बिट ऑफ ए अगर साइन बिट ऑफ ए 0 है तो हम लोग देखेंगे तो जो क्यू है, क्यू आप सॉरी फॉर द डिस्टर्बेंस. अगर साइन बिट ऑफ ए हमारी 0 है तो हम जो 0th बिट है डिविडेंड की, उस पे वन रख देंगे. उसको 0th बिट जो डिविडेंड की है उसको सॉरी उसको हम लोग 1 से रिप्लेस कर देंगे. अगर साइन बिट ऑफ ए अगर 1 है तो हम 0th बिट को 0th बिट जो कि डिविडेंड की उसको 0 से रिप्लेस कर देंगे, ठीक है. अब इतना हो गया. अब इसके बाद नंबर ऑफ स्टेप्स रिड्यूस हो जाएंगे, n इक्वल्स टू n माइनस वन. जैसे अगर नंबर ऑफ डिविडेंड में डिजिट्स 5 थी तो 5 की जगह 4 हो जाएंगी, ठीक है. फिर आगे नीचे स्टेप पे आएंगे. अब अगर मान लीजिए आपकी n की वैल्यू 0 हो जाती है तो ये स्टेप आपका ख़त्म हो जाएगा. अगर स्टेप n की वैल्यू 0 नहीं होती है तो ये आपका प्रोसेस चलता रहेगा. तो आपको दो बार कंपेयर करना होगा साइन बिट ऑफ ए, और उसी के अकॉर्डिंग आपको ऑपरेशन परफॉर्म करने होंगे. सो नाउ लेट्स मूव ऑन टू द नेक्स्ट स्टेप, विच इज़ so what if the number of bits become 0? So if the number of bits become 0, then for the third time we compare the sign bit of a. So if the sign bit of a is 1, we get accumulator as accumulator equals to accumulator plus m. And if the sign bit of a is 0, we directly get the answer, which is stored in q and accumulator denoted by a. So quotient is stored in register q and the remainder is stored in register A. So the whole process of the algorithm here stops. So okay, so now let's moving on to the next slide. So here are the steps involved. As I have already explained, you can read from the slide what are the steps. So step 1, first the registers are initialized with corresponding value. You all can read. I am moving on to an example so that you can be better explained. So in this example here, dividend q is equals to 11. Here in this question we are given with the dividend q, which has storing the value 11. So on converting 11 to the on converting 11 with the on converting 11 to the binary number, we get 1011, and divisor is m. Divisor denoted by m stores the value 3. So on converting 3 we get 011, but here as the number of bits the number of bits stored in m will be n plus 1, and n is the number of bits in dividend. N is equals to 4, so m will be number of digits in m will be 5. So we get 011. So we put the we put the trailing we put 2 zeros in front of the number, so the m becomes 00011. So minus m we got by the 2s by taking 2s complement of m, that is 11101. So here we see with the first step, as the number of digits is 4, so n is initialized with 4. Value of m, that is divisor, is 00011. Accumulator is initialized with 0, and q is 1011. So now first we compared with the most significant bit of the sign bit of a. Sign bit of a is 0, and if the sign bit of a is 0, we perform the operation accumulator equals to accumulator minus m after shift left aq, after shift lefting the value of accumulator and q. Okay, so we get the numbers as follows. So again we see that the most significant bit of accumulator becomes 1. So here we replaces the 0th bit of dividend with 0. So again now we reaches to the the value of n is reduced by 1. So here we get the value of n as 3. So again the following steps are performed, and as you can see that on reaching wait for a while. So as you can see, on reaching the step after performing the step 1, after reaching the value of n as 0, we get the value of m as 00011, a as 00010, and q as 011. So here we see that as the already reached the last condition, that is n equals to 0, and here we have seen that if n becomes 0, so what actually happens? So if n becomes 0, we compare the sign bit of a. So here you can see the sign bit of a is 0, so answer will be directly stored in the q, and we don't need to perform the operation on accumulator, that is accumulator equals to accumulator plus m. So here we get the quotient in q and remainder in, you can see we get the remainder in accumulator. So here on converting q, q contains the quotient, q contains quotient as 011. On converting it to binary, we get quotient as 3, and the remainder we got, that is stored in accumulator, is 00010. On converting to the decimal, we get 2. So we get answer remainder as 2 and quotient as 3. So thank you all of you.